Let's continue with the value at risk and consider a few examples. So, value at risk basically gives us the worst case scenario for the loss of a portfolio for a specific confidence level and time horizon for our investment. So, um, you can also convert the daily value at risk that you might have calculated using the daily, let's say, return data into the end-day value at risk using the simple conversion formula here by simply multiplying the one-day VAR with square root of n. So that gives you the end-day value at risk. So this is going to be correct perfectly if the successive days have IID normal distributions with mean 0. Obviously, this is a strong assumption and this might not be valid for your data, but you can still convert for the short term. Let's say if you are converting 1 day to 5 days or 10 days, you can use this conversion formula, although it's not going to be perfect. So if we visually want to see what this value at risk means, basically if you know if you have, let's say, profit and loss distribution for a portfolio, then value at risk is simply this quantile value that corresponds to the remaining 5% area on the tail of this distribution. If you are using a different confidence level, let's say 99% confidence level, then this red area will be 1% remaining on the left tail. So you will be finding this critical value, the quantile value that gives you this area on the left tail of the profit and loss distribution. So this is what value at risk tells you. Here's a single asset simple example. So suppose we have a single asset in our portfolio, which is IBM shares. And if we want to calculate the value at risk, let's say with 10 days time horizon at the 99% confidence level, we need to know what's the volatility of the IBM shares per day. So this can be calculated from the data, but suppose this is calculated already and given as 2% per day. So you can multiply this with the total investment to find how much standard deviation you will face per day. Okay, so 2% times this 10 million gives you $200,000 volatility per day. So now, under the normality assumption, we can use the critical value from the standard normal distribution. So if we are working with this 99%, as I just showed you the previous figure, if I'm assuming this returns, my single asset returns have standard normal distribution, I can look for the standard normal table to find the quantile value that gives me this 1% area. So that is written here as Z value. So this can be found in the standard normal tables, or you can use the MATLAB software to get this 2.33 as the quantile value on the that gives you this 99% area. So 2.33 times this 200,000, which is our volatility from the stock, that gives us $466,000. And if we want to convert this to a 10-day horizon VAR, then we just simply multiply this by the square root of 10. So we can get the value at risk at the 10-day time horizon.